All right, guys, welcome back. I think this is the 9th round of me going through the challenges in my book, The C# Player's Guide. Today, we are going to finish up the Catacombs of the Class challenges, which ran from, there's a bunch of these in here, starting with The Point through these. So these were just making a single specific class. These 5 here, the point, color, card, locked door, password validator. These 3 we were supposed to do just design using CRC cards or something similar, to just kind of think through how we might arrange code for these. Though in the videos for that, we went way above and beyond that requirement to do the design and we wrote, probably 80 or 90% of the code for those challenges. And today we're doing this last one, which is Tic-Tac-Toe, which does require, this actually doesn't require doing CRC cards, though we will do some CRC cards, but it requires making a fully functional tic-tac-toe game. So that is where we're going to start. And I don't think we're going to have time in this video to do any other challenges beyond that. So this is probably going to be it. So today we are making tic-tac-toe from scratch in C#. So I'm going to click this and jump over. I'm not going to read all of this, but let's do a quick, let's look at the, well, let's come down here. So they give us this, the book gives us a way to display it, though we could do it like, we have freedom to do it however we want. So let's see. The objectives are build the game of tic-tac-toe as described in the requirements above. So we'll go back and revisit those in a second. Starting with CRC cards is recommended, but the goal is to make working software, not CRC cards. And then there's this question that I'm very likely to forget to come back to. How might you modify your completed program if running multiple rounds was a requirement? For example, a best out of 5 series. All right, so let's look at these requirements here really quickly. So 2 humans take turns entering their choice using the same keyboard. So two human players. We don't need the computer to be able to play the game. The computer just needs to be able to run the game that 2 humans are playing. The players designate which squares they want to play in. You might consider using a number pad as a guide. For example, if they enter 7, they've chosen the top left corner. And there's a lot of ways we could do that, but that hint is something that I think we'll probably do. But so if they type in 1, it'll be the bottom left, 2 is bottom middle, 3 is bottom right, 4 is left, 5 is the center, 6 is the right, 7 is the top left, 8 is the top center, 9 is the top right. So that we will, however, maybe if we're going to do that, want to, well, I see a lot of people who will display somewhere what the options are somehow. So maybe we'll display that so people can actually figure it out. This game doesn't, from what I'm reading here, that isn't strictly required. So maybe we can assume the player can figure it out. Let's see. The game prevents players from choosing squares that are already occupied. So we will have to make sure we don't pick a square again. If such a move is attempted, the player should be told of the problem and given another chance. The game must detect when a player wins or when the board is full with no winner. When the game is over, the outcome is displayed to the player, and the state of the board must be displayed to the player after each play. And this gives an example of what that could look like. All right, so I'm going to move this off screen, and I'm going to, so I can still see it, but I want to show. So I'm using Adobe Illustrator here for my CRC cards. And I said this in the last videos where we were doing CRC cards. This isn't my normal workflow. Like, I don't usually use Illustrator and like on-screen CRC cards. Normally, if I were to use CRC cards, I would use physical cards and not use this tool. This is just an easy way to be able to record what I'm doing on the screen. I don't have a webcam that I can like point at my desk. So this is a just an alternative way to do it. So again, I don't recommend you just go buy Illustrator just to make CRC cards. The other thing is in like for something like Tic-Tac-Toe, honestly, I've done enough software design. I probably would just wing something this size and just get into the code and just start doing stuff. And for designs that are more complicated and I have to think through, I actually usually do it a little different. I got a whiteboard on my wall. I got a whiteboard, like a smaller thing on my desk, and I generally use those and use dry erase markers and sketch stuff out. And there's a lot of philosophical similarities, but so CRC cards isn't what I actually do every day, all the time, kind of thing. But it is a useful tool that's very lightweight and easy to work with. So that's why I covered it in the book. All right, so I've got all here. These are for the previous challenges: rock, paper, scissors, 15 puzzle, and hangman. We can obviously ignore those for the moment. I'm just gonna come over here and let's start talking through this design. So, okay, the first bulleted item here, and we can take this one item at a time. We can think through what the design would need to be for a single bullet point, a single requirement, and grow our design from that. So let's just start with, this is my template, so I'm just gonna duplicate it down into here. So 2 human players take turns entering their choice using the same keyboard. So this doesn't require any sort of networking or anything like that. When I see this, like there is a concept in here that sounds like something we should make a class for, and that is the players, human players. And then there's a responsibility here that needs to get assigned somewhere, which is being able to get a choice, from the keyboard. So I'm going to, so to me, given that this feels like a concept that makes sense to have in our code, I'm going to say we're going to probably have a player class. And then the responsibility here of let's get choice from the keyboard. That's maybe a good as good a way to phrase that as anything. Again, you don't need to. No one else but you, the people you're working with, would ever even see these these cards. So you don't need to get too like overly worried about the details. These are just things to help you brainstorm and think through how you might do it. And I actually, well, I learned last time that if I delete all of that, it's hard to get to select that text box again. So I'm going to leave a single letter in there so I can, because I think this is going to need a collaborator eventually. But all right, so get a choice from the keyboard. Well, I suppose we could say that this is going to have the console window as a class. I'm not going to make the card for that, but it does need to be able to talk to the console class to interact with it to get that choice. There's 2 human players. So again, this is something that we've talked about a little bit before. Like, there's going to be, I figure, 2 instances of the player class. Does there need to be? Could we just have a single instance? Yes, we could. We saw this earlier that there might be, we might, for example, the requirements in this challenge don't specifically dictate this, but it could have a requirement that says, get player 1's name, get player 2's name, and then we put that into, we would have 2 instances. They would each be given their own name, and this guy would maybe end up having a responsibility of remembering the player's name. So that way instead of saying player 1, it's your turn, we could say, instead of saying it's X's turn or O's turn, we could say it's RB's turn. Whatever the player's name is, we could use that instead. So I think we likely would have 2 instances of this, one for each player. Just like in the real world. We have a player, two players that are doing it. So I expect that we'll have two of these. Not everybody who does CRC cards have um, will make a separate card per instance. That's up to you whether you want to do that or not. I oftentimes will. It kind of depends. Like I'm not if I think there could be 30 players, I'm probably not going to go right player on 30 actual cards. I'll do something to just make it clear that hey, there's a bunch of these, and leave it at that. Uh, yeah, but in this case with two is yeah, I don't feel bad having two player classes. I think that illustrates it. It helps me keep track of it in my mind. Oh yeah, there's going to be multiples of these. Though I will almost never, um, if I'm using physical cards, I would almost never write the details on multiple cards. I would just write the details on a single card. All right, that's a lot for us. The single line. Let's move on. So the players designate which squares they want to play in. Hint: you might consider using the number pad as a guide. For example, if they enter 7, okay. So the players designate which square they want to play in. I think I don't know that like I feel like we've already covered that here. The player's gonna make a choice. The only thing that this line might bring up is do we want to like describe a separate class here that conveys like a location on the board? And I think it makes sense like to have that kind of thing. So I'm gonna just make this little like a location class, and I'm just gonna say this represents a location on board. This doesn't need any collaborators. It's actually very simple. So the idea would be, so this is, I think, I'm not sure, but this is probably, with a row and a column. So this should be a pretty simple class. But I do expect that so this guy, he's actually going to create locations and give them back to the rest of the game. So I do expect that we'll make this class. It doesn't have any collaborators, and yeah. So the game should prevent players from choosing squares that are already occupied. So one thing that we haven't captured yet is we clearly have a representation of like the board that's in there. Like something needs to remember what the state of the whole board is. Is this empty? Is it an X? Is it a O? So I think let's see. Oh, my template's gone. Hang on. I want that back. The template. How far back do I have to go? All the way. All right. There. Got my template back. All right. So we do need a board class that represents the current state of the board. And I think this has a sort of I'm just lets others change the state and also so this class is going to just represent the state of the board, whether something's an X or an O or empty, and it will have to be able to allow others to change it. We actually, out of the things we've done so far, I don't know that we've specifically seen a requirement that has stated that, but we are going to need that. So it's going to let others ask to update it, change an empty to an X, change an empty to an O, and also it needs to have some sort of way for the outside world to ask it what's in row 0, column 2. So it needs all of that, and that's probably it. However, for the player to get a choice from that isn't, the thing we're looking at, the game should prevent the player from choosing squares that are already occupied. I'm going to come right here and put prevents repeat selection square. So we're going to assign that responsibility to this class, though. You could make a different class for that, but to me it makes sense for this guy to have that. But in order for this guy to do that, he's going to have to know about the board. So he has to have a collaborator that is the board class. So he needs to be aware of this guy in the context, at least in the context of making a choice. Yeah, so if such a move is attempted, the player should be told of the problem, and the player should be given another chance. All right, so the game must detect when a player wins or when the board is full. So as usual with these, I tend to end up having a class that is that represents the game as a whole. So TicTacToeGame. So I'm expecting that there would be, so this is going to run a single game of Tic-Tac-Toe. So in order to do that, he's going to have to hang on. Let me use this one instead because it's got the collaborator list. All right. Let me do that over again. Run a single game of Tic-Tac-Toe. So in order for him to do that, he's going to need to know about the player class, and he's going to need to know about the board class. So he's going to have a collaborator of this and this. So he's going to kind of sit up here above everything else. And so this is going to entail ask player for choice, update the board. Now I think we're kind of to so the game must detect when a player wins or when the board is full with when a player wins or when the board is full with no winner, so a draw or a cat. So whose job is it to decide, to analyze the board and decide if there is a winner? I don't think it's the player class's job, but I think you could make an argument that you could put that on the board class and say, let's have the board class do that because it knows about the state, and these are questions about that state. These are, is there 3 X's in a row? Are there 3 O's in a row? Are there any open spaces left? So I think you could say that's a it is questions about that data, and so it would be reasonable to put it there. On the other hand, I think you could also say game, like the game logic itself, which is what this is, maybe belongs more up here. So we could put that responsibility here of like knowing, deciding, by looking at the board, deciding whether it is you know, a win for one player or the other, or if it's a draw. That and actually the way that the thing is phrased, the game must detect when a player wins, kind of seems to hint at maybe it goes here. Another possibility is we could make a whole separate class whose only job is to, like, we could, for example, make a class over here that is like a WinChecker, and give this guy the responsibility of detect whether a player has won, and also detect whether the game has ended in a draw. If we did that here, then this guy would need, like, whoever's making that decision does have to know about the board to make that call. So that's a possibility as well, that we could have just a whole separate class hanging out here that is kind of a minion. Like, this guy would like rely on this. He would have to know about the board, and that like separates the win logic from everything else. That's a possibility. Like there's something I kind of like about that, just because I think the code in some of these other classes is going to get somewhat big. Another rule that you can use to help you decide if you should make another class or not is that behavior potentially interchangeable for similar behavior but different stuff. So for example, tic-tac-toe, like there really isn't more than one way that we could determine a win. On the other hand, we could imagine players that get their input not from the console window, but from other things. I mean, maybe a mouse click or a tap on a screen if we had a graphical interface. It could be coming from the network. So because like it's easy to imagine, or even a computer, like an AI tic-tac-toe player, it's easy to imagine different flavors of this player. And that in my mind is a good reason to say this should be separate, so that like its reasons for changing are separated. This win checking, tic-tac-toe is such a simple game that there isn't like different variations or different ways you'd play the game. So there isn't a compelling reason to have this separated. So I'm on the fence right now whether to give that responsibility to here or make it a separate thing, though I am right this second leaning away from putting it in here. I'm going to leave this as it is. We'll finish out the design, and maybe we'll change our minds before we get done. So, and I will say that I'm pretty sure I have solved tic-tac-toe with this being a separate class and with it being in here and maybe in here. Like, I think I probably solved this in each of these ways. Like, I don't think it's going to matter greatly where these land. It's just what mental model works the best for you as the programmer. All right. Let's see. When the game is over, the outcome is displayed to the players. So, what I forgot to do here, suppose we are going to keep the WinChecker in there, this needs to be here. Check for a win using the WinChecker class. I'm not going to write that out, but And then once the game is over, then display final outcome. So, yeah, that's that. And then the last thing on here is the state of the board must be displayed to the player after each play, after each turn. And they give an example. So, again, we need to be able to draw the board. And the question right now is, whose job is it to display that? And again, we could like displaying the state of the board could go here. It is, again, it's a thing that's closely related to this data. But I do kind of like the idea of this board class being just it's just like a purely logical representation. It doesn't have any notion of how the human might be interacting with it. It's just purely this like in memory, like purely almost mathematical logical representation of it. And it isn't concerned with input from the human and output to the human. So I would lean, in this case, I would lean away from displaying this, from having this new responsibility of drawing the board. I would lean away from putting it on board itself. I don't think it makes any sense for the WinChecker itself to be doing that. Given that this is like interaction with the human, it could be, it does make some sense to put it here, and it could make some sense to put it here, and it could make some sense to have another class. The reason for doing it with the player is that it could be like, if you, let me scoot this back over here. It could make sense for the player class. Like it has been given a choice to, it's been given the task of get a choice from the human. So to just to just, as it's doing that, to say, oh, well, by the way, human, like this is what it looks like. What do you want to do? Could make actually a lot of sense. And then the interaction with the human and the fact that it is strongly associated with the console window is all put together in a single class. So all interaction with the human input and output lives there. That's a pretty good reason in my mind for why we might put that in the player class. But let's not commit to that right now. But that is a possibility. We could put that responsibility of displaying the state of the game there. We did kind of say display the final outcome, which I could be as simple as X wins or it's a draw, or it could be just a single console line. So this doesn't necessarily have to have a ton of interaction with the console window, but it is like it seems like this thing is already dealing with the notion of, well, we're making a decision here of who won, and showing that to the user. So it could be that this guy just has the responsibility to, like, we could just come in here and say draw the current board. Like, we could do that. And another possibility would be kind of like what we did with this WinChecker. We could make another class that's like a board renderer. That he would need to know about the board to draw it, and then draws the state of the board. So I could imagine, like I said, that responsibility could be in a separate class. It could go in here. It could go here. And I think any of those are workable. I think you could go down any of those paths. I do kind of like the idea, however, of having a separate class for it. So I'm going to put this over here. And I'm so this ended up with quite a few classes. Let me move this. This is all Hangman. I'm going to move it out of the way farther. So yeah, so we ended up breaking this out, and so this guy needs to, if we're going to do that, this guy needs to have a board renderer as a collaborator. So this breaks it. This what we have in cards right now is the most like it creates the most classes. The goal isn't to have lots and lots of classes. The goal is to have a working tic-tac-toe game. So lots of classes isn't necessarily by design, but the one like I do like that this again we were talking earlier about this idea of if it's swappable, like if we might want to do something totally different, that on its own can be a pretty compelling reason to separate it. And that's I think a good reason for this player stuff to be separated. I think that's a reason for this rendering to be separated. We might change our minds entirely about how we want to render the board and to just instead of having to modify code to just come back in to just make a board renderer 2 or a fancy board renderer or a colored board renderer, like whatever that is, and to be able to basically just just like go make a new class instead of having to modify existing code is actually really convenient. In fact, that's one of those principles of making software is if you can design things in such a way that you can grow the software by simply adding stuff instead of going back to existing code and changing it, that's usually a preferable design. So knowing that this is an area that might change, an area of volatility that might change, that's a compelling reason for this to be a separate class. And the same logic goes here. I don't, again, it's harder to imagine alternate like win rules, but you could make the argument there too. This, like, this could just be this. I don't know that we would actually swap this out, but to have something that just manages just the state of the thing, agnostic to all like the logic, is feels like a really reasonable thing to do. So yeah, we're gonna end up creating 1, 2, 3, 4, 5, 6 classes, but I think I'm okay with that. I like this plan. Like I said, if your plan ended up having the drawing lumped into here or into player or wherever, or the win checking is in here, or whatever it is, like there's so many ways you could do this. We've talked through a whole bunch of different variations, and I'm sure there's a lot more. This type of stuff, this design is one of those things where ask, what did I say last? Ask 5 developers and you'll get 6 different opinions. Like this is the ways that it comes out very different for people. And I think they all work as long as you can just sit down and say, oh, hey, I needed to make a change to, like, I don't want it to draw that way, I want it to draw a different way. You need to be able to look at the list of things that are available and be able to just like zoom in on it. So if we look at this and we say, well, I need to make a change to how it's drawn, and this is what my design looks like, where do I go? Well, board renderer stands out as, well, that's the guy that's drawing it, so I'm going to go there to fix my bug. As long as that kind of thing works well, it's it's probably fine. Okay, it's time to move over into code, and I'm going. Like I said, we're probably, as we're writing code, we're going to realize that some of this stuff is not quite right. But given that we've kind of broken this down, we're going to be able to work on these classes one at a time, which will be nice. So let's see. Let's go. Let's just start. And I'm going to start with the simplest thing possible. I'm going to start with this location. Now I'm going to move this off the screen so you guys won't be able to see it. So take a mental picture here. I'll have it off the screen so I can write code, but I'll probably drag it back on the screen here and there too. But it's time for code. Okay, let's see. So I'm just gonna make a new project here. I didn't realize I didn't have a project open, but that's okay. I'm gonna choose this console app, not the .NET Framework one. It's C#, it's console. And I'm not gonna be surprised if I already have a tic-tac-toe. We'll find out. .NET 6. Give this a second to create our new project. All right. It's time to write some code. So we talked about making a location class, and it represents the location of the board with a row and a column. I'm actually going to make this one immutable. So I think that's it for that class. Like this just needs to be able to have a row and a column, and we can create one by giving it a row and a column, and that's it. It's just a small chunk of data. Let's move on to something more complicated. Most of these classes, well, let me move this back over. Most of these classes depend on the board class to do stuff. In fact, all of them do. So I think it makes sense to tackle that board class next. So this represents this current state of the board, and it lets others change the state, and it can tell others about the state. So given that this is a tic-tac-toe board, we could do a one-dimensional array, but I'm going to do a two-dimensional array because it's just easier for me to wrap my mind around it, given that the thing itself is a two-dimensional structure. You know, the tic-tac-toe board is two-dimensional. And one thing we didn't specifically call out in our design is I don't know what type to put in here. But so we could, we could say, well, we're gonna. So this is a 3 by. This is going to be a 3 by. Well, I'm using int for a second here. I'm expecting I'm going to change that soon. But so this is the actual data storage, and it's a 3 by 3 array of right now integers. That is our board. Now, I could use an int, and I could say x is 0, y is x is 0, O is 1, empty is 2, or something like that. But I think in my mind, this is a good case for an enumeration, which we didn't call out in our design, but enumerations often don't get called out in that design. So I'm just going to make an enumeration that's like a cell type and we'll do empty first, X and O. So we could, like I said, we could use integers. We could use characters. We could, for example, make this be a character like characters like this, and then we could use like the literal character capital X and the literal character capital O, as well as maybe a space or something like that, or to represent these values in here. I don't think that is a bad idea. I've seen a lot of people do that. It does work. I have I would rather, to me, this defines the concept logically, and it ensures that we only really use these three values. We run a tiny risk of somebody doing something like, I'm going to throw in a constructor here, but it does run the risk of something like that, or that, or that. Like, it runs the risk of somebody putting something that isn't a legitimate value in there. So in my mind, I think it makes the most sense to stick with an enumeration. So we'll do that. The enumeration we just made. Now, this needs to allow others to change the state, and it can also tell others about the state. One, like, we could make this public, and that allows anybody anywhere to just reach in and just change these cells. One problem with that is it does act like and this is the book makes a big point about this. If we make it public, then it allows the outside world to do whatever they want to it, and which it could be malicious. It could be somebody trying to, intentionally abuse the system and make it do something that it's not supposed to do. Or it could just be, and this is, I think, the real thing, it could be accidental, where we didn't realize that we weren't supposed to do something. And while working in another class, we accidentally did, introduced a bug that changes data in a way that we weren't expecting it to change. So it's really more about bugs rather than like a security mechanism. So I'm going to leave that private, and then I'm going to make some methods. And I'm going to, so I'm going to have a set. We'll just call it set. That's a nice and simple. So we'll pass in a location, and we'll pass in a cell type. So this is, the intent is to set at a specific location a specific value. So at this point we can say cells at, I don't know what this is suggesting here. Cells at location dot row and location dot column equals new type, just like that. Oh, we need a void here. It's a void method. So that works. This thing could enforce the notion that the only thing that we should be setting, like, we should only be, the new type should not be empty, and it should also, hang on, one problem at a time, slow down, one problem at a time. One thing we can say is that if we could say that we should not be able to set, if it's already an X or an O, we don't want to overrule that. So this thing could say, if that the place that we're trying to, so if the location we're trying to set is not empty, then we are just going to return. We're done. So this will enforce at this level, making sure that people don't try and fill in, like, change an X to an O, for example. And we could also say that nobody should be calling set with an empty. So here's two kind of like conditions that I'm thinking right now, it might be worth checking for. These are, you don't need to do this. It's just something that's on my mind, so I did it. So basically, if somebody's asking us to do something stupid, we're gonna just do nothing. And there are other, like, if you get down a little further, and there's like error handling and exceptions that in C# that we could use here, and that might be a good alternative. Throw an exception here instead of just doing this. Another thing we could do is we could indicate whether this was successful or not. So we could make this a bool, and then we could return false here, and we could return false here, and then down here we could say return true. So that way this thing conveys whether it actually did what, it actually responded to that or ignored it. That could be useful in some situations. I don't know if it will be useful here. So I'm actually going to just undo that and just keep it simple. So, all right, so we have the ability to update it. We don't have the ability to get a location. So I'm going to make one for that as well. And this can just say return cells at location dot row and location dot column. So this will just, if somebody wants to know what's at some location, we'll just look it up in our little pile of cells and return it. Okay, there's one thing. So I think we're actually almost done here. I do want to spend a little, well, so this is going to say make it read only. We can do that. Let's do that. There's one thing that we haven't accounted for directly, and that is what state should these start in? Given that this is an array, when we say new cell type, this is going to, by default, allocate everything in this to 0 bits all the way down, which means that whatever the default value for cell type is what all of these are going to take on. So if we come down here and look, in our case, that 0-bit pattern will result in empty. So by putting empty first in the enumeration, it means, as our code currently stands, this is going to get initialized to all empty, which is actually what we want. So we don't actually have to do anything fancy here to populate this with something else. But had we put, had the empty been at the end, XO empty, then in this case, this would initialize that whole board to being completely full of X's. That's actually the reason why I put empty first, is so that it would initialize it to zeros. So I don't have to write extra code. But if you felt the need to do that, you could come in here and make a board class, and you could say cells equals. Well, so if I'm going to do that, maybe this part lives down in here, or maybe not, but we can just say for int row equals 0, row less than 3, row plus plus, for int. It keeps suggesting col instead of column. I always prefer to write it out. So there's code that would force these to all be empty. So if the enumeration was starting at X and we wanted to keep it that way, we could do something like this to get it the right way, or whatever other setup we feel like we need to do. We could do that. In this particular case, I don't need to do that, so I don't want to drag that code around, so I'm just going to delete it. And all right, so that's the board class. We have the ability, it hangs on to the state of the game. It allows the outside world to set it with some rules. There are some rules there, and it allows us to get the current state of any row and column. Anything that starts with get and set is a potential candidate for a property, but in this case, because we like the way this is, we would need we can't make just a simple property, because we can't make it just a simple property, other than I guess we could make a property for cells, but that would get and set the entire cells, like basically our entire data storage, and we don't want to do that. Anyway, the bottom line is there is a tool that I would normally use that we don't have access to yet, that's called an indexer. I would actually normally use an indexer. That's covered quite a bit later in the book in the operator overloading chapter. But to me, this would be a great fit for an indexer if we have that tool. We don't yet, so just a get and a set here make a fair bit of sense to me. All right, with that, I think we're done with that class. And let's make the board renderer class next. So I'm jumping ahead of myself here. So we've completed that. We've completed that. So now we've got a couple of these other classes here. And I think we can, I think this makes the most sense to do next. So let's work on that. So we'll make a public class board board renderer. And I think this can have just a single method that's like render or render board. And this needs to know, like we had the board list as a collaborator. So somehow this board renderer has to be aware of the board that it's supposed to draw. And given, so one way that it can get a hold of that is by passing it in as a constructor parameter. Another way is by passing it in here. So then in that case, we would have like a private read only board. And in here, we would say, store that in our field. And then we wouldn't need this. I spelled it. Board renderer. So either way, either of those two approaches allows this class to have access to the board that it's supposed to do stuff with. I kind of like having it be a given that the only thing this guy needs to do with it is have it here as a like it only needs it in the context of this render method. I think I prefer, like, if this were something that it was strongly associated with a board and it had like 17 methods that it needed to use the board for, I would, that other approach of passing it in as a constructor dependency and just storing it in the field makes a lot of sense. In this case, I like just passing it in here. This guy doesn't have to drag that around everywhere it goes. It just is told, hey, here's a board, draw this board. Okay, now draw that board. Now draw this other board. It doesn't have to be strongly tied to a specific board. Okay, let's see. So this is supposed to draw the state of the board. And we have in here, this is what the book shows. I have a hard time selecting that, but so we can generally stick pretty close to that. I don't think we need this. It's X's turn in here. Something went really weird and all of that. Something went really weird and all that. We're getting there. All right, so that's the gist. And let's see how we can actually draw this. So if you look at this, like each cell, so it's got like the frame, but then each cell is actually a space, a character, and a space. So we just want to come up with some code that can draw something like that. And what we can do is we can say, like we could do some loops. I'm not sure if, like, well, let me just do it this way. Console dot write line, not write line, console dot write. So this is for square one. Well, yeah. Let's make this simple on ourselves. Let's pretend for the moment that the board is always going to be completely empty. And let's just make that part work. If the whole challenge is hard, let's break it down and do something really simple. So let's pretend that it will always be empty. And there. So that's what it could look like if it's totally empty. In this case, these should be right lines. Now, one thing I want to do here is we could go for a long time and not like actually run any code, but let's actually do that. So we can just say new. We're only assembling half of our classes here. It's only half of the Avengers that we're assembling. But we can make a board. We can make a board renderer and a board. Oh, I must have undone too much there. All right. Okay, so this is going to create a new board renderer, and then we're going to render a new board. And we could run this now. So we don't have a complete program yet, but we can run this, and we ought to be able to make sure that we get something reasonable drawn on the screen. Okay, so there's that. That looks good. That's a good start. But now what we want to do in here is actually pull stuff out of the board. So what I'm going to do is use string interpolation. And right here for this middle space, I'm going to say board dot get new location 0, 0. And then right here, I'm going to do a similar thing, board dot get new location. Let's see, row is still 0, column is 1. Missing my curly brace. Board dot get new location 0, 2. Okay, so that's so now this first row has, instead of just using a space here, we actually get that value from the board. I know this is going to have a problem though, but let's do this. Let's come up here and so if we say board dot set new location row 0, so 0, 0, we are going to use cell type dot x, and then we're going to do an O, and then we're going to do another x. Row, column 1, column 2. Okay, so now here's a board where the top row is XOX, which this should be getting. So we should now see that pattern when we run this. And it does. There is a catch. So let's suppose we leave 0 and 2 empty. Actually, let's do that with the first one. We're going to see a small problem. It's displaying the name of the enumeration value, which is empty, which is going to throw off our whole. It's going to throw everything off. So we don't want to display the actual enumeration value here. Now, by the way, some people at this point will just say, well, then why don't I just use a character? I could just use a character, because if the board used characters throughout, and we were using a space character and a capital X and a capital O character, we'd be done here. Like, this would actually work exactly as it is. I explained my reasoning why I wanted that enumeration before. So that is, I just want to say that actually has merit. And if that's your choice, you can do that. Like I said, the downside to that is that it leaves open the possibility for somebody to put who knows what sorts of weird characters in there. Somebody could put a lowercase x in there on accident instead of an uppercase x, which could break all sorts of stuff. So the alternative could be, in this case, that we're dealing with cell types, but we want to do something to convert it to a character at the last second here as we're drawing it, to figure out what character to draw. So, for example, we could make a method. Maybe we make a private method because it doesn't need to be used by anyone else, but private character to character. And we pass in a cell type. So we could make this method that's like to character, and then we can just say, so basically we'll convert the cell type to a character, and that could be done. We can just say return cell type switch. So we'll just make a switch here. So if it's X, then we'll return X. If it's an O, we'll return an O. And otherwise, we'll return a space. So that can be that entire to-character thing. And now we could come in here, and in the middle of this string interpolation, we can just say to-character. And same here, to-character. Same here, to-character. So in this spot right here, we're going to create a location at that spot, and then we're going to say, hey, board, give me the cell type at that place, and then we're going to convert that to a character. It makes for a really long line. It says 172 characters. That is kind of crazy. But before we deal with fixing the craziness, let's just run this and see. That code has now allowed us to, we have a space now. So I think we've solved that problem at the cost of our code now is really complicated. And I want to solve that, but before I do, I'm going to, so this line doesn't need to change at all. I'm going to come in here and I'm going to make this, so row 1. Row 2. So now that should be the whole thing. So this code right here would, in fact, even if we come in here and say, we'll just add in a few more. So now this should get us the whole board is being drawn that way. Okay. So we could, at this point, we actually could say, well, the board rendering is done. This is working now as it's supposed to. I really don't like that code. So I have a thought in my mind that I think I want to do. And that is, what if we make a character array make a 3x3 character array, and then we're going to say for int row 0 row less than 3, for int column equals 0, columns less than 3, column plus plus, and then basically, so rendered characters at the row and column, abandoned mutex exception, row and column equals to character board.get new location row and column. So this thing will just go across the whole thing, row by row, column by column, ask the board for what's in there, get a character for it. So now I have this. I actually kind of like the name rendered characters, but I'm going to shorten it just a little bit. And now this can be shortened to something a lot more manageable. Oh, yeah, that's right. Okay. And that, and I'm going to now just replace this line, this line. So I think this is a lot easier to understand. There's still a lot going on here. Um, and I'm sure there's more we could do with it, but I do think I'm happy with it as it is. I don't feel a need to do necessarily more. I think doing this made it kind of split out a lot of this logic from being embedded in here. Like for me, this logic of like this interpolation here, where it's just we're gonna just put character 00, character 01. Like that is fairly straightforward, rather than what we had before, where each of these had all this random stuff in there. So I mean that is a flavor of this that I think will draw the board. Let's run this again and just make sure that it looks like it's still working correctly. Yep, it does. So I'm happy with that. And then so that means we're done now with the rendering class. I can let's come back and look at the classes we've got. So we've completed this, we completed this, we completed this. This player class we're not done with yet. Same with this WinChecker. Let's do that player class next. And then I think before we do the WinChecker, we'll work on this. So let's move on to that player class. So this one's actually fairly simple. All we said that this needs is some way to get a location, get the choice. Oh, and I think we said that this needs a collaborator on this one. This needs to know about the board because it needs to be able to prevent repeat selection of a square. So we'll give this the board. And then we will say console.writeLine. What square do you want to play in? I'm actually going to do just a console.write, and then we'll do a console.read line. And I'm going to, the pattern that they describe, that the book describes, says, use like the numpad for this. So I'm just going to convert this to an int32. And I need to turn this into a location at some point. This is the way I've defined this method. It has it returns a location. So I need to convert it before I leave this method. I'm sure we could come up with some sort of like equation that would, given an int, it'll compute a new location with a row, a correct row and a correct column. I think I'm gonna just start simple here. Just kind of hard code this, and just say, well, if they typed in a 1, then what they're looking for is actually new location. So that's actually row 2. It's at the bottom because the 1 is at the bottom left corner, and then 2, it's new location, row 2, 1, and then 3, and then we need to get our others in here. So in theory, as long as the user enters good data, this should create a location. Oh, so I've only solved half of the problem there. We said it needs to get a choice from the keyboard, but also we need to prevent repeat selection. And that's the reason we got this board. That's the reason we intentionally got access to this board, is so we could say, all right. So now we can do something like if board.get at that location. So if that is empty, then this is the one we want to use, return location. Otherwise, we need a loop. We need to do it again. And there are a few ways we could do that, but perhaps the simplest is to just say something like while true. And that's technically all we need to do here, because this will, like, even though it's a while true, even though this will loop forever, when we find something empty, we're gonna return it, and otherwise we start over and run the loop again. You know, one thing I do want to do here is make this a method. Hang on, let me describe what I just did. All right, so I select a bunch of code, and then I hit Control R, and you can see down here at the bottom, Control R is pressed waiting for the second key of the chord. So I took my finger off the R, but I still got my finger on the Control key, and I hit. So basically now I'm hitting Control M, which is refactor into a method. So this will take whatever code you got selected and put it into a method. And there's a lot of times where this doesn't work very cleanly, or in order for it to do it, it starts to do a whole lot of crazy fancy things to be able to, depending on where you do it. So depending on what code you've got selected, this will come out either really clean or it'll come out really horrible. And you should be very conscientious of that when you use it. There is well, let me finish this and I'll hopefully remember to point out that there is up in the menu, there's a menu item for it. So right now it's waiting for me to type in the name. I'm going to call this to location, because this is going to convert this int choice to a location. So, and you can see that it renamed it in both of these places, and this is now the new method. It made it private, which is what I would have done. It also made it static, which I might not have done had I manually written it, but I think it's a good choice. And apply. You can also just hit enter when you're done too. Now let's see. I'm just trying to remember where. It's this one right here. So I went to edit, refactor, extract method. So now, I mean, now like this method is pretty straightforward, because it does one thing only, and that is convert a choice to a location. And now this code just got a lot easier too. So now it's easy for us to look at this and understand what it's doing. So while forever, but although we will escape it here, ask the player where they want to play, convert that to this, and then we're going to convert that to a location, and then we're going to ask the board what state it is in there. We'll see if it's empty or not. If it is empty, we know we found a good choice. So otherwise, down here we can say console.write line. That was not that space is not open. Try again. Okay. So if we enter in a good option, then we're going to come in here and we'll end up in this if statement, and we'll just return it. If we don't enter in a good option, then we won't get into this if statement. We'll hit this line, that space is not open, try again. We'll come back up here and we'll say, what square do you want to play in? That's that. So let's do this. I'm gonna ditch my renderer for a second. I'm just say new player. So again, I'm assembling half of my classes here, my instances here. New player dot get choice. Pass in the board. And now you know what? New render. I'm gonna want to see the board in front of me to be able to make this work. All right. What square do you want to play in? So this right here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I pick 9, this should tell me, no, that's not a good choice. Try again. It did. 8's the same way. So is 3. So is 2. But if I pick, say, 5 right in the middle, it should work, which it did. So it ended the program because once we found a good choice, this will return, and then that's the end of our program. So we're getting there. And I think, like I said, this player class is working with some caveats. And again, we've kind of played loose with error handling. If I run this again, if I type in Y, it blows up, it crashes. Input string was not in the correct format because we couldn't convert to an int32. For the short term, I think it is like we could do some check, like it's. So I will say right now, it is okay for it to be that way. It is okay for us to, for the moment, assume that the player is going to do smart things. In the long run, over a career, you can't afford to do that. Humans are going to do all sorts of stupid stuff, and we really don't want. We can't just trust that the human's going to do smart things. For right now, it's okay to do that because right now we don't have a full arsenal of tools to handle all the different types of errors. So, but when, for example, when you learn about exceptions, you could use a try catch to ensure that if this blows up, that you handle it and say, hey, that what, in that case, that wasn't good input at all. Not only is the space not open, but that's enter a number between 1 and 9 instead. So that would be an improvement here. I mean, the poor man's version of that might be to do something like choice as string equals, given tools we've got, we could do this and say choice as string. So if so we could do something like if choice as string equals null, then we could do something like console.writeLine. That is not a valid choice. Try again. And I'm going to actually say continue to the next pass. And we could say if choice as string dot length is greater than 1, or choice as string dot length equals 0. So if it's an empty string, or if we entered more than one character, then we do console dot writeLine. That is not a valid choice. Try again. Continue to the next pass through the loop to ask again. If choice as string, so at this point it's just a character. We know that because the length is 1. And anyway, so if choice as string at index 0, the first character, I think we can do this. Let's see what happens. Is less than 0, and choice as string 0 is greater than 9, console.write line is not a choice. Try again. So hopefully you can kind of see how much code we're adding here just for the sake of error handling, which is another part of the reason to say right now you don't need to worry about that. We're just going to trust users are going to be smart. But the reality is you can't always trust that. All right, so you can't always trust that, and you probably do need to have a fair bit of error checking, especially when it comes to handling what users do. So let's see. If I type in ABC, I think that should work. That lands. It won't be null, but its length will be greater than 1, so that should land us here. And if I just hit enter, I should get that length of 0. If I hit Control X, that gets me the null. What I thought. God, I want to try that one again. Run that again. Hitting Control X should. Stop it. I want the breakpoint right there. I don't remember how to get null. Still, that's interesting. So it gave me a character. It's that 18. Why? Like this should have been. Let's see. I feel like this should have landed us because it's just a random character. Why did let's see. Why didn't that land in here? So choices string is less than 0 or shouldn't it be? If it's less than 0, the character 0, or if it's more than 9, pretty sure that was it. Let me run that again. I think that needs to be an or. Okay. I feel better about that. I just hit Control C, which is like it kills the application. All right. So in general now, like with that validation, we've done. So now at this point, like our program isn't crashing, which is fantastic. Again, like there's a lot of error handling there. So having said that, this is the poor man's version of it, and there are other tools out there, including again, if I had a full arsenal of tools, what I would actually use is not convert.to in32. There's a I can just do int.parse, which is very close to the exact same thing. More importantly, there is, again, if I had the full arsenal of tools, which I don't, which is a reason why we're not necessarily worrying too much about error handling, is there is a try parse in here. And this actually returns whether it was successful or not. But the catch is you put your it has an output parameter, which is something that I don't want to explain in this video. It's too complicated for it. The book does cover it in level, I think it's level 34. It's the one that talks about like advanced method stuff. This is passing by reference. So it is in there. We just haven't gotten to it, and it's just an extra complexity that we don't necessarily want to deal with right now. But so this way, so in this case, like all of these scenarios are actually handled with this try parse. So instead of all of this, what we could do is something like if try int.tryParse, if not int.tryParse, console.write line that was not a valid choice, and then continue. So that there's code in the base class library that already handles a bunch of that stuff for us. So now I can do I feel like something still blew up on me there, and I have no clue what it was now. Oh, okay. It was probably this. Yeah, so the one thing that this doesn't handle, this int.tryParse, if I type in a number that's not in the 0 to 9 range, then this thing can't handle it. So what could, if we wanted to handle that, what could we do? I'm way off in the weeds. I don't actually expect people to be solving all this sort of like error handling, especially because, like I said, we haven't talked about this. I think it's reasonable to just assume that the player's going to enter good stuff. But if we really wanted to handle this, we could do something. One thing we could do is we could just say we return null here. We express that this can return null. And now this guy can be null. And now we can say if location is null, then we do a similar thing like this. So if the number wasn't a valid number, so here we can tell that it's a valid integer. At this point, we can tell that it was within the range. And I'm sure there's a way that we could squish all this together. But okay. So I think at this point our error handling is actually pretty robust. If we really wanted to get super fancy here, we could do and to location choice does not equal null. At this point, we know you can do this. Okay, that is the most compact way to do all this error handling. And this it gets the choice in this variable. If this was false, if we couldn't parse an integer, we display this. Otherwise, we continue down this evaluation and take that choice variable, convert it to a location, and check it for null. So if it is null, then we'll also come in here. So the only way we will get past here without doing this continue back to the start is if we entered in a valid number, which is why down here when we say to location, this claims that it could return null, but we already know that it's not going to be null. So I put this exclamation mark, which is the null forgetting operator. This is the I know more about null, whether this can be null, than you do, compiler, at this point. So don't give me, because without that we get a compiler warning right here. Converting possible null reference, converting null literal or possible null value to a non-null type. And we're saying, yes, even though this thing claims that it could be null, it ain't gonna be, or we would have found that out here. Again, I happen to have done it this time. I don't. Nobody should need to convert it to. Nobody should. Don't feel like you need to do any of this error handling. We can go back and just assume that they. In fact, I think I'm going to, but. For now, it is safe to assume that a human's going to enter in good data. In the long term, that's not wise. But like I said, right now we really don't have a full arsenal of tools yet in terms of error handling. And we will soon. We'll get there. But right now it's okay to not really do error handling. Other than, like I said, we'll leave this in. The one thing we will do is check to see if the square is already in use. So I guess I'm gonna leave this code like this. It has like almost no error handling. It would be better to handle the errors, but for right now, it's okay to not worry too much about that. And at this point, I think we have our player class made. So we've completed this and this and this and this. And we need this class that like run a game. And we need this class that'll tell us if we've won or not. And I'm gonna do this, the TicTacToeGame class next. Partly because we're already kind of started here. Like we've already got the beginnings of that. Like here we're creating a board and we're creating a player and we're creating a board renderer and we're kind of like running some of the logic there. So let's just make public class TicTacToeGame. So, and I'm going to make a method here called run. And this will, in here we'll create a new board. And we'll create a new board renderer. And we'll create 2 players. And what else do we need? That's maybe it for now. So while, and I'm just going to say while true. We'll keep this simple for a moment. Renderer.render. So draw the board and then ask well, let's do this. Player 1 dot get choice. We'll give it the board so it can actually make that choice. And then we'll say board dot set it to an X for now. We need to deal with the fact that the players are going to alternate. And that's it for the moment. And then up here we can just say new tic-tac-toe game .run. So it's only going to be the X player over and over again. What square do you want to play in? 1, 2, 3, 4, 5. Okay, so in general, it seems like it's working. We do need to alternate players. So let's have another. So we got 2 players, and we'll have player current player equals player 1. So this variable will tell us who should actually be doing it. We'll start with that being player 1, and then we'll ask the current player instead of always player 1. And then we will do between things, we'll say player current player equals, well, after the first time we do want it to be player 2, but what we really want is whatever it currently is, we want it to be the other one. So current player equals, well, we could do it this way. If current player equals player 1, then we're going to switch current player equals player 2. Else, in every other situation, current player equals player 1. So this will change between the two players. And now we need to do this. We need to be able to tell which player. We need to be able to choose the cell type based on the player. Given the players, like we don't know which one. So yeah, we don't know which one, whether to use X or O. And there are a couple of choices here. One is we could say current player equals player 1. Use the cell type.x. Otherwise, if it's player 2, use cell type.o. I think that will actually, I think that'll work. I think that'll work, but one thing that would be kind of nice is what if, and again, like our design did not cover this, partly because designs like this can't cover all the details. But given that we have two players, it might be nice for the player themselves to keep track of which like token, whether they're X's or O's. There's a lot of other ways we could do that. Like for example, we could just have like an int player number, or we could even have like a single player class since it's all the same. We just have a single player class and then have it. And then here for like this alternating player thing, we could just have a variable that stores cell type instead of player. So we could do something like cell type current player equals cell type dot x. And then down here, we can just say, basically, we would just do that. And then we can do, if the current player is cell type dot x, current player equals cell type dot o. And if else, current player equals cell type dot x. So we could just alternate back and forth between the two cell types. That kind of breaks this. I think instead of that, though, what I want to do, because I feel like the token that a player is using is a part of the player, I actually think, in my mind, it makes sense to just make that be a part of the player. So cell type token. So I prefer to do it that way. And now we can come up here and say cell type dot x, cell type dot o. And now in here, we would just say set current player dot token. Again, there's at least a dozen ways that you could do this, and all of them have validity. So pick the one that makes the most sense to you. But I do like that version. We can probably run this again here and just make sure. Sure, why not 22? Oh yeah, that's right. I forgot. We ripped out all the input validation. So we have most of a game here. The only thing we haven't done, and we know about this because of our design, the only thing we haven't really done is decide a winner, like know when we're at the end of the game, and also display the final outcome. Those are kind of the two major pieces that haven't been done yet. And we said we're going to make another class for that, so we could say public class WinChecker, which again we could just this logic we could just put in the game itself. I wouldn't feel too bad about that, but public bool has x1. So we can just have a method. Let's make this simple for a moment. And while not as x1. Kind of pass in the board. Okay, so while x has not won and not as O1 and so while not x has won and not O has won and not it is draw, so we need to make all right, so three methods that if any of them become false, then the whole expression becomes false and we'll drop out of the loop. So the game will end when one of these returns true. And now we just need to write some code that'll tell us whether X has won or O has won. And this one's the easiest, so let's start here. So basically, it's a draw if the entire, well, let's assume that it's a draw if the entire board is full. So we can just say for int row is 0, row is less than 3, row plus plus, for int column. So basically, if we find one, if we board.get new location row column, if we find a spot on the board that's empty, if we find one that's empty, then we know it isn't a draw. Return false. Otherwise, if we get through the entire board, we've looked at every row, every column, and have not found an empty one, everything is an X or everything is an O, then we're going to say return true. Now, strictly speaking, it's possible that the board is full and X1 or O1. So either this should maybe check to see if X has won or O has won, or maybe we rename this to be is board full. And yeah, so now what it's doing and what it says is doing are in alignment, because now it's like this will return true, even if you have like a board full of X everywhere. This would still count it as, it'll say that it's full without claiming that it's a draw, because in that case, X would have won. Now we got to do these. And so there's a way, I'm sure, so if X has won is if you find a row where everything in the row is X. or a column where everything in the column is X, or one of the two diagonals. And I'm sure we could write like a loop. So, for each row, go down and check. We could do that, but I think I'm going to keep it simple and just say if board dot get 0, 0 equals cell type dot X and board dot get new location 0, 1 equals cell type dot X and board dot get new location 0, 2 equals cell type dot X. Return true. So this checks a single specific one. Let's see, it's row. So this is if X gets all the way along the top, then we return true. I'm gonna let's run that really quick. So right now the only way we can actually win the game. So if X gets the top row, so this should cause X to win. Oh dang it! I chose the wrong. Did that on the wrong turn. Let's try that again. 7, 4, 4. Dang it. 8, 5. Okay, now 9. So the game ended because a player won. But so this line's really messy, and I think honestly some of the complexity here is just that it's all these like new location, new location, new location. What I want to do is come here to get, and I want to make an overload. Public cell type get int row int column. Return. So if I do that, then now I can actually just call it this way if I want. So I've got multiple choices now. That's still a really long line. But, all right, so what I'm going to do here, and again, we could write logic. So I'm doing this kind of in a very manual way. So we've got a line for each row and a line for each column. So if 0, 0, and now we're just going to flip the order of all of these. So this checks all the rows, this checks all the columns, and then we need to check the two diagonals. So if board.get 0, 0, well, hang on. Copy this line because it's mostly what we want. If board, so 0, 0 and 1, 1 and 2, 2, return true. And now we want the other diagonal. So 2, 0, 1, 1 and 0, 2. All right. That code is kind of a beast. But we check each of the rows specifically, we check each of the columns specifically, and we check the diagonals. If any of them are all X's, we return true. Otherwise, we've checked all the possible patterns for X to win, and we return false. So now I should be able to get a win here for X, and only X, using any combination. So if I do, say, 4, yeah, I'm just testing out a couple of examples here. That looks like it's working. Like I said, this code is quite complicated. We could like there's a loop here. We could loop through each row. So for a row from zero to 2, check all the things. For same here for the columns, and then check the diagonals. Like we could handle that in a using a bunch of loops if we wanted to, and that might make the code simpler. I'm not sure it actually would. If we did have loops, it would make it really easy to support like a 4x4 or a 5x5 tic-tac-toe thing. Like if the tic-tac-toe board can be of any size, then if the tic-tac-toe board can be of any size, you would need to use loops. In this case, where we're only trying to support a 3x3 board, this kind of stuff, like it's just hard coding. Like I want to check this row and this column specifically could work, and I'm okay with that. Another thing we could do that might simplify the code, I want to try this out and just see. Let's suppose we said for int row is 0, row is less than 3. So I guess I'm making what I want is a Boolean array that is so what I want to do is basically compute like pull out the value from the board and check it once. So match row column equals board.get row column equals cell type dot x. So now I have basically this. By the time this loop runs, this will contain a two-dimensional array of whether the things at that spot was an X or not. And the thing I like about that is at this point now I can just say if match 0, 0 and match 0, 1 and match 0, 2 instead of all that. So like a line that looked like this got turned into a line that looks like this. And I like that a lot better. It kind of breaks the problem into 2 steps. There's step 1 here that says, tell me if I've got an X or not. And then once I know whether I've got X's or not, I'm just going to say, is this an X? Is this an X? Is this an X? And like, this could be equals true. Could do that for all of them. But we don't need to because this will either be true or not. But I feel like this code is substantially So let's see, I'm doing columns here, so this should be all right. That's a lot of code. Like I said, there could be some loops in here. And actually at this point, it starts to be easier to see what those loops could look like. Like to do this, you could just say something like for int row equals, I don't know. Anyway, I'm actually mostly happy with this code. And so I'm going to leave it alone with the caveat that we do need to do has O1. Now I could just copy and paste all of this code and put it in here, and now I've got and I'd have it working. I don't love copying and pasting that much code with that complicated logic because there is a pretty reasonable chance there's a bug in here. And if there's a bug in here and I've copied and pasted it, I'm going to have 2 bugs that I need to find and fix instead of 1. So what I'm going to do is make a private method here. Private bool has 1, and we're going to pass in the board, and we're going to pass in the cell type. And what I'm going to do is I'm going to move this code into here. And then instead of checking it for X, I'm going to check it for the type. So have a parameter that is that type. And now we'll just say return has 1. So we'll call our private method with cell type.x. And then in here, now we can say return has 1 board cell type.o. So given a board and a cell type, so now this is flexible because it's got that parameter in there. This method is flexible and it can handle it regardless of the type. We can pass in the type that we wanted to check for. And all these do is has X1, has O1 is just based on passing that in. And now if there happens to be a bug in here, there's only one place to fix it instead of 2. With that, I think we could have O win. So this should make O win on that column. And it did. Okay, we were actually super duper close to being done. Got all this win checking done. And so I'm trying to think, what do we actually need to do? So we need to say what the outcome was. So we'll leave this loop if somebody has won or if we found a draw. So at this point we can say if WinChecker. So one thing I want to do is I want to render the board again. Renderer.render board. So this is for the final time. We render the board and then we say if, depending on what happened, if WinChecker.has x1 console.write line x wins, else if WinChecker.has O1 O wins, else it was a draw. So let's just see if we can. So now it displays the actual final version of it. It tells us who won. So I actually, at this point now, I think it was a draw. I think the only thing we're actually missing is it would be nice right in here to say whose turn it is. And we can just say current player dot token. So that right there is actually exactly what is in the book here. It's X's turn, got the board. What square do you want to play in? All right. So I think we're there. I think we've completed tic-tac-toe, and we played a couple of games to just kind of test it out. We could do a bunch more of that to see. This program ended up being 165 lines of code. That includes, curly brace lines and empty lines. And I mean, my style tends to be pretty compact. Like some people will have curly braces for all this stuff here. Some people might have ended up with a switch statement instead of a switch expression, so that could have ended up longer. Like your version might be substantially longer than this. But if you've gotten this far, then you will have a like. I gotta say, like tic tac toe seems like such a simple thing. Um, but being able to create something like tic tac toe is a really big milestone. Like being able to get to this point where you took something like I said, it sounds simple, but this is hundreds of lines of code and a lot of logic that does a lot of different things. There's a lot of corner cases you have to think through, and just tons of stuff that you gotta like be thinking about. And if you're able to, honestly, if you're able to complete this tic tac toe thing, then C sharp. Sure, there's more to learn, there's more to do. Like we're at this point in the book, we're like halfway through it or something like that. But if you can do this, then you can probably do pretty much anything if you just, put in the time to do it. And hopefully this, being able to, like I said, your solution, I'm certain is going to look very, very different from mine. That's okay. I like if I found somebody else who had as much experience programming in C sharp as I do, their solution would also be very, very different from mine. So it's not a problem that your solution and my solution is different. So let's talk for a second though about what happens if you really, really struggled with this challenge. Like what happens if the reason you're watching this video is because you tried it and couldn't get the pieces to come together. Hopefully by going through this video, you've seen some of the tools and the tricks, the techniques that I've used, and maybe hopefully you're at a point where you can say, I think I understand that better now. I understand how to do this and how to do that. What I would suggest is after watching this video, if you did struggle, take a break, let us sink in for a little bit. So I before I get too far, I should say you're not alone. This is like I said, this is a hard challenge. And I honestly, given how my code tends to be pretty compact and pretty dense, you might have had to write 500 lines. Like other people might have written 500 lines of code to accomplish the same thing. Um, that isn't a bad thing. It's just a thing. And so we, like I said, we are talking about a very substantial challenge. But just because you couldn't get all the pieces to come together and needed to come look for help, um, is not a bad thing. You're in good company. The but the main thing to take away from this is it's one thing to like read the book and say, oh yeah, I see these examples and I think I know how to do it. These challenges are meant to force you to like get your actual hands on actual code and make actual things happen. And and no amount of like me describing in the book, do this and here's this example and it looks like this and it looks like that. No amount of doing that is going to get you that experience. You have to do the challenge to get the experience, and it is going to be hard. This is a boss battle, and this is like the pinnacle of this entire Catacombs of the Class boss battle. It is meant to be difficult. It's meant to push you, and if it caused you some pain and suffering, good. That was my hope. Um, it's part of that like the crucible of learning how to program is sometimes you have to take a problem and struggle with it. Now, if you were going through this and like, you know what, I just don't know that I understand how classes are actually supposed to work, it maybe makes sense to go back, and now that you've kind of been burned by the refiner's fire here a little bit, to go back and say, maybe I need to go read that section about constructors again because I do not understand why I've got these constructors, or maybe it's properties, or whatever the thing is, or maybe I should go back now that I've played with this and reread the section on the chapter on object oriented design. So if you're really struggling, there might be some specific things you can go back and say, look, um, this is what I felt like I was struggling with, so I'm going to go reread that. Um, but what I would suggest, if you did struggle, maybe go back and reread some stuff, take a break and let your mind absorb kind of the things we went through. And then I would suggest just trying it again, just going through Tic-Tac-Toe again. Yes, there's going to be some things you're going to be just like, well, I'm just mentally copying and pasting what Arby did in the video, and that's okay. There's nothing wrong with that. I want you to take the parts of this that you feel like were useful and use them. Because I like a lot of the things that are in here are things that I would have done in 1,000 other programs. I've just done it enough that I didn't just copy and paste. Um, and just recreate it, and hopefully it goes better the next time, having seen it. I mean, that, like, this is a player's guide. It's meant to kind of help you understand the answers and help you see through these tough challenges. So it's okay that it was hard, and it's okay that on your second time you're gonna do better. I guarantee it. You're gonna come away from it saying, oh, you okay, I understand why we like now that there's these classes, I'm going to make my own player class. I didn't do that my first time, but I'm going to do that this time. Or, I didn't have a WinChecker class. I'm going to give that a try this time. Whatever it is that are these things that you looked at and said, well, that worked well, so I'm going to use that. Take the things that worked well and use it. Anything that didn't work well, anything in here that you saw that you didn't like, don't worry about it. Like, skip it. Do the things you want. Because like I said, if I asked another C# programmer with as much experience as I have, I'd get wildly different answers here. So take the parts you like and ditch the parts you don't like. So give it a break and then try it again. Read some of the sections that you feel like you might have been especially weak on. I have seen several people get to a point where they're like, oh man, I'm going to just start over on the whole book. I'm not going to tell you not to do that if that's really what you feel like you need to do. In general, though, you probably don't need that. There's probably just a couple of things that you want to reread and focus on those rather than start over from the beginning. And then I would suggest, once you get done with Tic-Tac-Toe, even if it is you kind of reusing a lot of the building blocks that I've got, take a different challenge, a different but similarly sized challenge, and do that instead. For example, rock, paper, scissors would be a good example. And there was the design for that, and an earlier video I actually wrote most of the code for that. So if you want to go back to, I think that one was the 7th video. If you want to go back to that and check your answers against that, but something simple like rock, paper, scissors. Or pick something similar. I mean, the 15 puzzle could be a good example. Just if you to kind of prove to yourself that, hey, I've come, like, yes, it was hard, but I've learned stuff and I'm getting better at it. Like I said, I'm where I'm at after I'm almost to 16 years of doing this professionally, and realistically is probably 15 years before that from the first time I wrote my very first program. So, like I said, it's going to be easier for me than it might be for you if you're just starting. So don't worry if it's hard. Like it's going to be hard. What else? A couple of other things I want to point out, that if it is hard, don't try to make it harder for yourself than it needs to be. I see a lot of people who try to do more than the challenge asks for because they think it's the right thing to do. If the challenge doesn't specifically call out doing something, you can assume that you don't need to do it. And so the error handling, I think, is a good example of that. You could do that, and it would be like, at this point, now that it's mostly working, to go back and say, well, I'm going to handle that scenario where somebody enters bad data. Get the thing working first and worry about that other stuff later. And then for any specific thing that you're really having a hard time with, like, don't feel bad about just like, find something that you feel like it's okay to take shortcuts, especially in the short term. And like, in a lot of ways, this kind of is a shortcut. The quote unquote real version might have used some loops and stuff so that we could change the size of this board to be not just 3x3, but any size. It'd be kind of nice to have that flexibility, but you don't need to. And so to just take a shortcut, just say, well, I'm just going to check this. Or if you're like, I don't know how to check the diagonals, leave that off for a little bit. Like any of these things that are especially difficult, try to find a way to work around it. And I like we kind of saw that in the other challenge with the hangman, where ideally we'd pick from a list of 10,000 words, but in the code that I wrote, I just picked from 5 words. Like, it's okay to take those shortcuts and deal with the rest of it later. Like, it's, you know, solve it in a simplified version first. And by the way, I think we saw that in here too with the win checking, where we said, well, what if we just don't check everything? What if we just check the first row? So that type of thing of like, let's just do the poor man's version of this, and we can fix it later. We can grow it later, because having a working poor man's version is better than having a mess of code that doesn't actually solve anything. So it's better to have had just this one line here that will allow the player to win when they get just the top row. And once you have that working, then it's easier to start to say, well, okay, if I can handle the top row, maybe I can handle any row. And if I can see how to do rows, maybe I can see how to do columns. And if I can do that, then maybe I can do the diagonals. So you just kind of like work on it one small piece at a time. Like I said, break it down to as small of chunks as possible and just solve that little chunk. So keep it small, keep it simple, and grow it from there. I don't know if there's anything else there's probably a ton more I could say on this, but this video has been going on for practically forever. So I am going to stop it here and call it a day. But yeah, like I said, this is a tough challenge. If you were able to successfully complete it, fantastic, great job. You deserve all the experience points that you got from doing it. If you struggled, like I said, it's okay. You are not alone. Lots of other people are struggling with it too. It's meant to make you work for it. It's meant to push you through that crucible, that refiner's fire, to make it so that you come away with a much clearer understanding of how to actually make code, rather than just reading a book and just saying, oh yeah, I think I understand that. But like, these challenges are meant to force you to understand it. So it is hard. Expect it to take time. Don't be surprised if you spend a little while on it. But when you get done, you'll have proof that you actually can build a non-trivial program. Like, this is a big milestone to be able to get here. So congratulations if you made it there. Good luck if you're still working on it. Use those suggestions, and of course, drop into the Discord server and ask if there's some particular problem that you're just really struggling with. So I think that's it for now. I'll stop the video and I'll see you next time.